It's like the same idea as this. One of my favorite things to always ask people is to write out the following sentence. There are 3 twos in the English language. You can only use the words that I said. There are three twos in the English language. You can only use those 8 words. The sentence. How do you write that? There are 3 twos in the English language. You can't. You can only use one of the twos. Which one do you use? But there's no T. There's no 3 twos.
I got it.
Anyway.
Is there no answer?
I don't know. I have no idea.
I think I did it. Look it up. I think
Yes! That is awesome! I've never thought of that.
Wait, I want to see it. What does it say?
Go up there and see it.
Can you rewrite it? Yeah, wait, wait. I need to take it.
Yeah, write your name on it.
He's writing.
Awesome.
You're so funny.
Well done. Well done. I've been saying this for years and no one's ever thought of that. That is awesome. I never even thought of that.
That is wonderful.
Alright, so a couple properties.
That's like it's basically an impossible. What are we writing? What's it? Solving equations of wait, solving exponential.
When you're dealing with exponential equations, one of the things that you try to accomplish is you want to get this. Some base to an exponent to equal some base to another exponent. You're trying to get that property to happen. Because if that happens, as we know from earlier this week, when you're dealing with logarithms, you've got a couple of different properties. The 2 main properties that we deal with, there's 4 main properties that we deal with. Log base b of b is 1. Log base b of 1 is 0, sorry. And then the other one was log base b of b to the x is x, and b to the log base b of x also is x. Those are our 4 main things that we deal with when we're looking at exponential and or logarithmic equations and setups. So what you're trying to do here is, if you get 2 bases that are identical on both sides of an equation, one of the properties states that if I take the log base of that same base, the exponent drops. So if you think about keeping equations balanced, if I take this and write it out as the log base b of b to the x and log base b of b to the y, what happens?
So when you just want like
X equals y. These undo one another, and you get x equals y. So what you try to do sometimes when you have exponential equations is that you're trying to figure out a way to get yourself what's called a common base. Okay? You try to get yourself a common base so that this step can occur. Now, if you get a common base, the generic rule is you can go straight to x equals y. You don't have to show that step, but that's in the grand scope of everything. That's technically what you're doing to both sides to undo the base. Okay? That's how you're able to work with exponents. So if I look at a problem like this, where it's, 4 to the 3x equals 8 to the x plus 1, I need to try to figure out some sort of a way to rewrite that as a common base. So I have to think in my mind, 4 and 8 have a common base of 2. I see where you're going with that, but you could rewrite them as having common base 2. 4 is 2 to what power? 8 is 2 to what power? 3. So what you do is this. 2 to the 2 times 3x equals 2 to the 3 times x plus 1. Do you now have common base on both sides? So technically, if I take the log base 2 of both sides, my exponents drop. But I don't need to show that step because I have these bases being the same. So then I get 6x equals 3x plus 1. Plus 3. I was making sure you guys remembered the distributive property. Congratulations. So, solving for x, you get x equals 1. 3x equals 3, and x equals 1. Now, what's nice about exponential equations is that they are so unbelievably easy to check your work with. What's 3 times 1? 3. 4 to the 3rd power, well, is 64, because if you think about it, 4 squared is 16. Multiply that by 4, you get 64. What's 1 plus 1? What's 8 squared? Does it work? And this is where, probably not as much today you need to worry about it, but we will start to see a lot of extraneous solutions possibly when we deal with logarithmic equations, because they get to be a little bit goofier. Okay? That's one way we do this. Obviously, not too scary. So, do that one. Sign and date that for me, would you? Ouch. Hey, you get to share this day with our oldest son's birthday. And Valentine's Day. I have 2 boys. Yes. So you rewrite it. Are the bases the same? When the bases are the same, your exponents can drop. You don't have to show the step of log base 3 on both sides. And you get 4x. Subtract the x. And you get x equals -2. Now, same deal. Double check it. That becomes 9 to the -4th. And then the other side becomes 3 to the, what is that, -8? Yeah, it has to be. Because, right. Because if you break it apart, you can break apart that -8 as being a 2 times the -4. So 3 squared is 9, then you have 9 to the -4th on both sides, and it works itself out. Okay? What's that?
This is like the last Tuesday that Valentine's Day is going to be on for like the next 8 years.
Oh, okay.
Yeah.
Look at duck.
Wow.
We looked it up this morning.
Now, this is when you actually have to show it. It's when you don't have the possibility of having the same base on both sides. Because last time I checked 2 and 7, they do not share a common base. So what you wind up trying to do, you can't see, all right, fine, whatever. So what happens here is that you need to use the property of log base b of b to the x. Because if I log base 2 on the left-hand side, what would I have to do to the right-hand side? Log base 2. Numbers are jealous. You have to get, well, if you get one child a toy, you got to get the other child a toy. It's just the same thing. It's true, but when it comes to Nerf guns, if you don't buy the same exact Nerf guns for each child, then it becomes a problem. Yes, ma'am?
I know when my brothers were little, you know, like Power Rangers.
Yes.
It was just a big thing. My dad, anytime for Christmas, they'd both get like the exact same things. And so we have like multiples of everything.
What I found that with Nerf guns, if you buy 2 different styles, but you buy 2 of each. So one kid gets one, the other kid gets the other. Then at the next holiday, the opposite ones. And then you save the really good ones for yourselves. Yes, ma'am.
My dad has a collection of Nerf guns at his work that he uses for demos and his past. And him and his coworkers have Nerf guns on the way.
Might as well.
And we should do that here.
So what's log base 2 of 2 to the x? X. Now, remember yesterday I told you there's a mysterious button on the calculator to give you decimal approximations? Remember how to find that? No.
Oh, wait.
Alpha window 5. And then you get your decimal equivalencies. Okay? A lot of times with stuff like this, I could have you write it out in an exact form.
So like,
Yeah. You could write it, I could ask you for the exact answer.
2.80735949.
Or I could say it's log base 2 of 7. Log, it's the same idea as, remember last year when you guys did solving right triangles and you left your things in simplified radical form? Same deal. I could ask you guys either way. I could say give me a decimal, or I could say give me in simple in standard form.
How much do you want to
Yeah.
spend?
I don't think I'm going to ask you 2 to the x equals 7.
If you ask for decimal, how much?
I usually go to 100. I usually go to the 100. That's pretty normal for me on that one. Oh, what's the wrong one? So many files. Nah, no fun in that.
What did you do your first year of teaching? When you didn't have like all these things.
I had to make it all.
Oh man.
Well, actually, you know what? I had most of the files, and then you start to you accumulate. You know which ones you want to use, which ones you don't.
So like the first few years, you just kind of trial and error.
Yeah. A lot of book work, and then you start to customize it to what works better for students.
basically your first year.
Yes. Not really.
So when you have the smart boards, you have to like start all over.
So what I want you to think about here, guys, is that these become, they're still exponential equations, but they become longer. Multi-step, okay? What's the first thing you're going to do? You add the 2, okay? So you add the 2. Then what?
Multiply by 4.
Multiply everything by 4.
Oh.
And now what do you do? How do I get the exponent to drop? Log base. Okay. Excuse me. So now on the left-hand side, you're left with a kind of like a linear equation. Then you have 3x plus 1 is some crummy looking number. No, let's finish it. How do you get x by itself? Subtract 1, and then what? Divide by 3. So technically, you could do this, subtract 1, and divide by 3, and that's your value of x. This would be an exact answer. You're moving everything around like you would normally prior to pressing any button whatsoever in a calculator. Now, I do this a lot. I do this a lot where I'll ask you to write it out before you put it in a calculator, because, well, one of two things. First of all, it helps me see if you have a clue of what you're doing. But secondly, it helps me to see whether or not, or find an error, okay? Because you could, in theory, have this answer written out, but then go to your calculator and mistype it. Happens all the time, okay? If you remember this kind of idea from last year when you guys did trig, sine, cosine, tangent stuff, did Seb or whomever ask you guys to write out what you were doing before you put it in the calculator?
It was, he like said we could read it, make it handy.
I always like to have you guys write it out because it slows you down and it makes sure, that way you know what you're looking at, okay? It's kind of one of the things that I do, but that would be an exact answer, and then you can go from there and finish it out. All right. I don't know. E to the x squared plus 3 equals 4. Okay. E to the x squared plus 3 equals 4. What's the first thing you're going to do? Subtract the 3. So I get e to the x squared is 1. Then you just take the natural log. Remember, natural log stands for log base e. Okay. So you take the natural log of both sides, and you're going to get x squared equals the natural log of 1. Now remember, log base e of 1 is what? 0. What's 0 squared? 0. What's e to the 0? 1. What's 1 plus 3? 4. Didn't it work? Sure. Yes. Because what happens is a lot of times you're going to see some of these properties go back and forth within the answers as you're simplifying them through. But it comes to the idea that you have to remember, guys, you have to remember that natural log is log base e, okay? That's one of the things that happens a lot. People forget that and what it means, and then they tend to forget these two properties, okay? I'm not doing log equations today because that's the ones that get really messy. You start to get into logarithm equations, you start looking at where you're going to have to do properties. Don't write this down yet, but when you have two logarithms of the same base and they're adding between them, what does that mean is going on? Multiplication. So technically this is the log of x plus 2, x minus 3, equaling the log of x plus 29. And then you have to start foiling and going from there. Now, yes sir?
Could you subtract log x plus 9 from each side, and then you divide the x with the log x plus 2?
But how are you going to solve for x?
That would be log x plus 6 minus 3
Think-
over x plus 29.
Before you make it too complicated, think about that. If I exponentiate it, what's the base of that log that you don't see? What's the base of the log here? If I do this, all this junk drops. Solve for x.
Okay.
So you're going to have to do a lot of property stuff as we get into logarithms. You won't see it as often with exponential, but you see a ton of it with logs. I want to go spend a day on that stuff as opposed to exponential. Exponential's quick. You'll be done with it in no time. Okay. What I want you guys to do tonight is these. So this is what, 8.6, page 505. Second hour had about as much time as you guys did, and I think most people got up through about 37 before they even got out of there. They'll fly right through them. Okay? Yeah. 8.6.
It looks like a 5 you just didn't.
Nah, there's a dead spot every once in a while on the board. Okay? Yeah, Jen. And I'll leave it on the. I'll leave it up here for you guys.
I am like 95% sure that I'm either not going to be here tomorrow or I'm going to be here for only part of.
It's fine. It'll all be online.
Oh, I do. I just wanted to let you know.
Yeah, no, it's fine. No worries.